Welcome to qnawire.
Our question says that ball B moves in the positive direction of an x-axis of speed v, and it collides with the stationary ball A at the origin. A and B have different masses, and after the collision, B moves in the negative direction of the y-axis at speed v over 2. So A, in what direction does A move? And B, show that the speed of A cannot be determined from the given information. Okay. Well, we orient our plus x-axis along the initial direction of motion and specify angles in this following way. So I wrote it out here. Theta is equal to minus 90 degrees. Okay. And phi here is, and that's for particle B, which is assumed to scatter downward. And phi here is greater than 0 for particle A, which presumably goes into the first quadrant. We apply the conservation of linear momentum to the x and y axes, respectively. So doing that here, we have mb times vb is equal to, for x, vb mb or vb prime cosine theta plus ma va prime cosine phi. For the y, we have 0, is equal to mb vb prime. And since we're dealing with the y, this is sine theta plus ma va prime sine phi. Okay, so if we divide the first equation by the second equation, we end up with, since the fact that VB, so this is what we're given in the beginning, this is part A, by the way, is equal to V, and VB prime is equal to V over 2. We have MA VA prime is equal to, or times the sine of theta for the y part is equal to MB V over 2. Then we have MA VA prime. For the x part, this is going to be cosine phi which is equal to mb times z. Okay, so now dividing, we'll call this equation 1 here, and we'll call this equation 2. Going to the next page, taking 1, dividing that by 2. This is equal to, or this is going to give us, this is going to give us the tangent of phi, since sine over cosine is tangent of phi, is equal to 1/2. So the phi then is equal to the inverse tangent of 1/2, which is 27 degrees, or 1 over root 5. So there's our solution for part A. Now for part B, using that value for phi that we just found in part A, VA prime then is equal to root 5 over 2 times the ratio of MB over MA times V. Okay. But since we're lacking numerical values for V and for the mass ratio, we can't fully determine the final speed of A here. So that's what we're asked to prove, and that's what we showed here.